Welcome to chapter 7.1, where we talk about sample spaces and events. It says an experiment is an occurrence with a result or an outcome. The outcome is an uncertainty before the experiment takes place. The set of all possible outcomes is called the sample space for the experiment. So a few things have gone on here. So in chapter 7, we're now dealing with all of this probability stuff, which means that this section is going to seem very repetitive because we actually learned it from chapter 6, and now we're just doing the probability aspect. So we're going to be doing some sort of an experiment where each result is going to be called an outcome. It's going to be an uncertainty before the experiment takes place. And then once we have all of your possible outcomes together, that's going to be called your sample space. That is going to be the set, all of your outcomes in one. So for example, if we were to do a dice roll, right? What are all of the different options that we can have on your dice, right? Your sample space. We could roll a 1, a 2, 3, 4, 5, and all the way up to a 6. So this would be considered your sample space. All the possible outcomes. Whereas we could say the 6, the event of a 6 happening is just one of these possible outcomes. One possible outcome. So for example, let's say in our experiment, we're going to flip a coin and observe the numbers facing up. Your outcomes on the coin is either a heads or a tails. So your sample space, right, we list out all of your different outcomes. So it's going to be either a heads or a tails. So the cardinality, the total number of options that we can have is a 2, either a heads or the tails. So then how many of, in your sample space, what's your cardinality of your sample space? We get 6 total possible outcomes. Whereas here, let's say E is just your event. What's the cardinality of E, cardinality of rolling a 6? Well, there's only one way to roll a 6. That's if the 6 pops up. So it says in this section, we tie in what we learned from chapter 6 about the sample spaces, the set of all possible outcomes, and tie it into the experiments where we want a specific outcome. So some more quick examples. It says determine the outcome in the sample space for the following experiment. We cast 2 dice, we're rolling 2 dice and observe the sum of the numbers facing up. So our outcomes can either be, right, if we're talking about 2 dice, let's say one of our sample spaces, the first one is 1 and a 1, right? So the sum would be 2, right? So that's our lowest number we can have, and we're going to go all the way up, right? So we can get a 3, a 4, a 5, a 6, all the way until a 6 and a 6 get rolled, which is 12. So your sample spaces are all of those different outcomes. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and a 12. Those are all of the different ways on a 6-sided dice and 2 of them to be rolled to get your sum, right? If that's a little hard to understand, this one was from a 1 and a 1. This one can be from a 1 and a 2, or a 2 and a 1. Let's see, this one, a 1 and a 3, 3 and 1, 2 and 2, and so forth. Okay, that's how we're coming up with your sample spaces. Now, in our experiment, notice that we didn't say if this was distinguishable or indistinguishable, but for right now, in this particular experiment, it doesn't matter because we're looking for the sum of the what's occurred. So even if you had an indistinguishable one, you're still going to get a 1 and a 1 or a 1 and a 2 or 2 and a 1 to have the same value occur. So let's look at this experiment. It says creating a decision tree to show the sample space. Now we worked with a decision tree back in chapter 6.3, I believe, to get kind of a little bit more comfortable on how to create all of these decisions being made. So we're going to see it again here. I do recommend when you're doing experiments that decision trees are a great way to look at all of your outcomes all at once. So if you are having a hard time, if we're not just talking about dice, a decision tree might be where you want to go. It says in a survey, it was taken of a high school graduating class of 2010 and was divided into those who went on to college and those who did not. Those who went on to college were further divided into those who went to a 2-year and a 4-year. All graduates were asked if they were working or not. Find the sample space for the experiment. So what I would like you to do is to get some more practice creating a decision tree, pause the video, and create the tree. So in our survey, right, we divided the group up into those who went to college and those who did not. So I'm going to label college and no college. Now it says those who went to college either went to a 2-year or a 4-year. Now everybody was asked if they were working or not working, working or not working. And regardless if they went to college or not, they were still asked if they went straight into work or did not work. So your sample space, all of your different options, starting at the top, you could go to a 2-year college and work, a 2-year college and not work. You could go to a 4-year college and work. Ooh. A 4-year college and not work. You could also not have gone to college, but still work. And no college and no work. So this would be your sample space. All of the different ways that we could have possible outcomes. So let's talk about events more specifically. So if we take the above survey and are interested in the event that a 2010 graduate was working, we are interested in a subset. Remember that word from chapter 6.1, a subset, a set that is contained in a bigger set, right? So we are specifically looking for some graduate, right? Some high school graduate that was working. So looking at the above, who would fall in that category? Well, a 2-year college worker, a 4-year college worker, and someone who didn't go to college but was still working. So 2-year work, 4-year college, and then work, or no college, but still worked. That would be the event we were looking for. Those would be the people we would be hoping to further talk to. And you can do it on all sorts of ways. You could say, hey, no work, or those who just went to the 2-year college, 2-year college or not work, any of those, right? A very specific one event would be perhaps a 2-year college and a work. So therefore, right, we just talked about events. Therefore, given a sample space as the collection of all possible outcomes and an event E, a subset of that outcome, the outcomes of E are called favorable. It's what we're hoping to come up. So a favorable outcome. We say that E occurs in a particular experiment if it's an element of an experiment. So something like this, okay? Let's keep this as just saying maybe it's a coin toss. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We tossed our coin 10 times and observed a heads coming up. That is our favorable outcome. That's what we really wanted to happen. So of those 10, 1, 2, 3, 4, 5, 6, a heads came up 6 out of the 10 times, which means the remaining 4 observed were a tails. Again, we don't have context to this problem. It's just bringing meaning to what this is. The event is what we're going to be hoping to come out. So E is considered favorable. And this being not E is the complement. What we weren't really interested in. Keeping in mind, to get not E, we're taking your whole sample space, that whole, what is that, rectangle, and we're subtracting out the favorable to get to the other result. Now let's do a few more quick examples. Now what I would like you to do is pause the video and try just the next 2 on your own. It says we roll a dice and observe the number facing up. Great sample space numbers 1 through 6. Now your event is the number facing up is odd. So of all of these numbers here, choosing the odd ones, a 1, 3, and a 5. So when you go to roll your dice, we're hoping to find a 1, a 3, and a 5 to come up. These would be the ones that we'd be looking for or counting during the rolls. Now in example 2, it says we roll a red and green die and observe the numbers facing up. Find the outcomes of the event. Okay, so let's say E is the number, or some of the numbers showing is 6. Now, they are telling us we have distinguishable, a red dice and a green dice. So distinguishable, we know what is what, right? Which dice through which color, right? So the sum of the numbers showing is 6. So I got red 1 and let's say a green 5, which means if I flip them around, the red can be 5 and the green can be 1. That still counts up to 6. Let's do it again. Let's see, the red is 2, the green is 4. Okay, which means if I were to do it again, then the red can be 4 and the green this time can be 2. That totals up to 6. Let's try it again. There could be a red 3 and a green 3. Oops, not 3. And let's say I flipped it around this time. Let's say this time maybe the green is 3 over here and the red is also 3. If I have included this one, is there an issue? Yes, even if I change the order, maybe the green one came first instead of the red one, notice that the red one is still 3 on both and the green one is still 3, which means we cannot count this as an alternative. That's not okay. So any sort of double counting, we're going to get rid of. Now, if we were talking about just indistinguishable, you would only have these 3. Let's say they were just both red dice, so you can't flip it around. Let's try it again. It says the sum of the numbers is showing a 2. This time we're going to label your event as F. The sum of the numbers showing is 2. So we could have a red 1 and a green 1. And then coming right off of what we talked about, if we listed it again, green being 1 and red being 1, right? We've already counted for that. So this is where it would have to end. Now, if we're asked for the cardinality, hey, how many different ways can this happen? Well, we have 1, 2, 3, 4, 5 different ways here. And again, over here, we only have one way of it happening. Or above here, how many different ways can we get an odd number on a 6-sided dice? Well, there's 3 different ways, either a 1, a 3, or a 5. So keep in mind, we're going to be using this a lot more because we're going to be compounding this with probability. Now, one additional thing that we're going to be doing into the mix, or throwing into the mix, is now union, union, intersection, and complements. So after learning about the above in chapter 6, we can now apply it to experiments and find favorable outcomes or a combination of that. Union, keep in mind, is that U-looking one, or cap is another way to say or, either, or both. Intersection is the one that looks kind of like an N, which stands for and. It could also be but or however. But or however. Usually it follows some sort of a negation of the next one. Or a complement, which means not. So let's try example 3. So in our example, we are rolling a dice. Let E be the outcome that you roll a 5. Great. So E, we're looking for a 5. Now F is the outcome is an even number. 2, 4, and 6. Now the outcome is either a 5 or an even number. What would that look like in the math way to represent that? Well, it says either a 5, okay, a 5 is E, okay, either a 5, or, right, either or, and I might highlight this either, here, either a 5 or an even number, which is F. So E or F. So E is either a 5. Oops. You could have either a 5 or a 2, 4, or a 6. Now, if there's anything repeating, we only have to list it once, which in our case, we don't have any repeats. Now let's try it again. The outcome is a 5 and an even number. What does that look like? Well, you said even number is an F. We have F right here. We said a 5 is E. And is this looking one, that upside down U. So either it's a 5 and also an even number. Is that possible? No, that is so not possible. 5 is not an even number, so this is an impossible event. You could have rephrased it to have something. You could either say it's a 5 and not an F. So 5, but not even. So if it's not even, it's odd. Therefore, it's just E5, right? You could have mixed it up as well. You can do a bunch of these different things. You could say it's not a 5 nor an even number. Not a 5 nor is it even. So it can't be a 5, but it can't be even. So that means we're looking at 1 and 3. So not 5, not even. So not 2, 4, or a 6. So you can play around with it in a lot of different ways. So let's have you try the next one on your own. Roll 2 dice. One is red, one is green. So pause the video, see what you can do. It says the red die is 2. Okay, red dice is 2. The green dice is odd. Seems pretty familiar. 1, 3, and 5. Find the outcome when the red is 2 and the green is odd. Okay, we're working with 2 different dice now. We're looking for the red dice to be 2. Okay. Red dice is 2. And the green dice, and being the keyword, and the green dice F is odd. So 2 and 1, right? Red is 2, gotcha. Green is odd. Can I do it again? Okay, red is 2, green is odd. 3. One more, red is 2, green is odd. 5. How many different ways can we have this? E and F, we have 3 different possible ways to have this outcome. Now pause the video and see if you can try example 5. It says, let R be the event that it will rain tomorrow. Let P be the event that it will be pleasant. Let C be the event that it will be cold, and H the event that it will be hot. Express in words R and not P. Well, R being rainy and P being pleasant, but P is negated. This is not P, not pleasant. So this is the event that it will rain tomorrow. And, or you could say rain tomorrow, but not be pleasant, and not pleasant. Not be pleasant. Okay, that is only one way you can say the sentence. You can say it multiple ways. You could say the event it will rain but not be pleasant tomorrow. Anything that negates the P pleasant, but still say and or but. Or however. Will, however, not be pleasant. So then express the next one with words. Are or, so rainy or, pleasant, P, and cold, C. So pleasant and cold have to go together. So something like the event that it will rain, or it will be rainy, a rainy, is that how you spell rainy day? Or, so it'll either be a rainy day or it will be pleasant and cold day tomorrow. Come on. Something along those lines. So the event that it will be a rainy day or it will be a pleasant and cold day tomorrow. Or yeah, tomorrow. Now let's do the opposite. So express in symbols. Tomorrow will either be a rainy day or a cold and rainy day. Sorry, did I? It will be either be a pleasant day or a cold and rainy day. It will, however, not be a hot day. All right, so pause the video, just see what you come up with. So the days here kind of break everything up as to what goes together and what doesn't. So either it's going to be a pleasant day or, okay, I'm going to put this or here, or it'll be cold and rainy. Cold and rainy go together. Cold and rainy. So it's got to be cold and rainy together, right? So it'll either be a pleasant day or a cold and rainy day. However, no matter what, it will not, however, be hot. Not be hot. So, and not hot. Right? We said this and because the next one is negated, can be either and, but, or however, as long as the next one is negated. All right, that is it for chapter 7.1.